Hello and welcome to this lecture. So today I will start measures of skewness. So far we have already discussed the measures of central tendency and measures of variation. So today we will start measures of skewness. So first we discuss what is skewness. Skewness is nothing but asymmetric, which is not symmetry. In skewness, that is not symmetry. The study of the shape of the curve. In skewness, we do the study of the shape of the frequency distribution or shape of the curve. So what is symmetry? Symmetry is a curve like this. This is symmetric. Symmetric curve. Or you can also say this is the normal curve. So this is the symmetric and also known as normal curve, in which the normal curve, this is the bell-shaped curve, and these two sides are identical, and this curve is about the midpoint, mean, median, and mode. If any distribution having the equal mean, median, and mode, this distribution is known as normal distribution, and this curve is known as normal curve or symmetric curve. In which in symmetric curve, mean, median, and mode are equal. At the same, the mean, median, and mode will lie at the same point. So if mean, median, and mode is equal, then the distribution is normal, and this curve is normal. This is the bell-shaped curve, and the both two sides, this side and this side, both are identical. If this is not normal, then the curve is skewed. So suppose a skewed curve, and there are two types of skewed curves: positive skewed and negative skewed. So if we have a curve like this, so here this side and this side is not identical, and the left right side there is long tail. So this is here. This is the mean, and this is median, and this is mode. So in this is the positive skew. This curve is known as positive skew, in which mean greater than median greater than mode. So this is the symmetric curve or normal curve. If curve is not symmetric, so this curve is either positive skewed or negative skewed. And another curve like this. Here the long tail is left side, and this is the mode. Here this is the median, and this one is mean. And if mean, that is curve is known as negative skew. This is the negative skew. So there are three types of curve. First is symmetric, a normal curve in which mean, median, and mode are equal. And if the curve is not symmetric, then this is skewed, asymmetric. And there are two types of skewed: positive skewed and negative skewed. In positive skewed, the long tail, the right side, and the mean greater than median, greater than mode. In negative skewed, the curve is like this, where the mean is less than median, less than mode. So this is important curve, and we always use the curve like a normal curve. So if you this curve, if you collect the data and the data are plotted on the graph, then you will see the curve generally like this. Suppose take an example. Take an example. Suppose this is the x-axis and this one is the y-axis. If you want to collect the height of the students, so take the variable height on x-axis, and here this is the height, and on y-axis number of students, or you can say the frequency. So take frequency on y-axis, and height, the unit of height we are taking in feet. So 0, 1, 3, 2, 3, 4, 5, 6, 7, 8, and so on. And here the number of frequency, number of students. So you will see this is the minimum height, and here is the maximum height. Height is increasing like this. So there is few number of students whose height is very less. So if you drop the number of students and height measured in feet, you will see the data like this. The very few person whose height is very less, and the maximum student whose height is average height in the maximum, and the very few student whose height is very high, greater. So this curve, you will see the curve like this, and so you will find a curve like this, and this curve is nothing but the normal curve. So you will see the height between 5 to 7. The maximum frequency and the less than 5, there is minimum frequency, and there is greater than 7, there is the minimum frequency. So average height, the maximum frequency will lie on 5 to 7, and the minimum number of students whose height is less, and there is also minimum number of students whose height is maximum greater. So there is maximum number of students whose height is between 5 to 7. So this will get at the peak, and so frequency will start from low, go to the high, and again go to the down. So this curve is generally known as normal curve. So this is the normal curve, and this is the skewed. There are two types of skewed: positive skewed, and this one is the negative skewed. In positive skewed, mean always greater than median, greater than mode, in negative skew, the mean is less than median, less than what? The graph is like this. Now the measures of skewness. The method to obtain and find the value of skewness. So there are some methods which is used to find the skewness, coefficient of skewness, and these are coefficient of skewness, and this is generally denoted by beta 1. So first coefficient of skewness is based on measures of central tendency, and this is given by Carl Pearson's. So this beta 1 is nothing but can be calculated as mean minus mod divided by standard deviation. So if the distribution is symmetric, means normal distribution, then mean and median are equal, so beta 1 become 0. And if mean greater than median, then beta 1, the value of beta 1 is positive. If mean less than median, then beta 1 is negative. So you can find whether the beta 1, that is the coefficient of skewness, is positive or negative. So using this formula or another formula is also, you can also find coefficient of skewness by using this formula 3 mean minus median divided by standard deviation. So you can also find the skewness using by this formula. If the data are measured on ordinal scale, or you can say positional average, then you can find the beta 1, that is the coefficient of skewness, by using the formula, that is Q3 minus Q2 minus Q2 minus Q1 divided by Q3 minus Q1. If the data are based on ordinal scale and positional average. So you can use this formula to find the skewness. And if the value is positive, then the skewness will be positive. If the value of this get you negative, then the skewness is negative. If beta 1 is 0, then this is the symmetric, not skewed. And one formula is also used to find the coefficient of skewness on the basis of moments. So you can also use the moments, and this is the moment mu3 square divided by mu2 square. So we just explain how to find the moments. Moment is nothing but we are just using the frequency distributions of the data. Mu3 is just you use this formula, mu3 is equal to, suppose mu r, rx center moment, this is nothing but 1 upon n summation x minus x bar to the power r. This is the rx moment. If you take r is equal to 1, Then this is the first moment, r is equal to 2, this is the second moment. So from this formula you will get the moments, value of different moments. Now the next measures we are going to discuss is measures of kurtosis. Measures of kurtosis. Measures of kurtosis, we just do a study of the thickness and flatness of the curve. In kurtosis, we study of thickness and flatness of curve, and this will give you the variation of the distribution, whether the variation is high or variation is low. So just see the graph. Suppose this is the symmetric, or you can say normal curve. There are three types of kurtosis, or you can say we can show you the three types of this graph just by changing its scale. So this is the one, and this is like this, and this is. So here you will see the midpoint center is the same of all three graphs. But first is very big, and second is medium, and third one is, suppose this is A, this curve is B, and this curve is C. So A is highly big, so the variation is less. If the curve is concentrated and big, so variation will be less. If the curve is scattered and flat, then the variation show that variation is high. So here A is known as, the curve A is known as leptoquartic. Leptoquartic. B is known as mesoquartic, and curve C is known as platyquartic. So in leptoquartic, the variation is less in comparative to mesoquartic, and in platyquartic variation is high. So suppose if data is spread, this show very much spreadness of the data. This curve. If the data is concentrated, then this is the concentrated at the same position. So, but the central value are same. Mean is same, but the variance are, standard deviation are different of these three types of curve. All these three types of curves having the same mean but different standard deviation. In A, standard deviation is less, minimum standard deviation. B type curve, standard deviation is greater than A, and C type curve, standard deviation is highly standard deviation is. Now for finding the coefficient of kurtosis. So how to find the coefficient of kurtosis, and this is denoted by beta 2, and this is always use the moments. By using moments we can obtain the coefficient of kurtosis. So here moment is mu 4 divided by mu 2 square. If beta 2, the value of beta 2 greater than 3, then this implies that the curve is leptokurtic. If beta 2 equal to 3, this implies mesokurtic. If beta 2 less than 3, this implies platokurtic. So you can just having an idea about the distribution, that what type of and how much variation are there. So this is the measures of kurtosis. Now let's come to the next topic. So our next topic is correlations. Measures of correlations. And just write correlation analysis. So far we have discussed only univariate, and now if we want to study of more than one variable, that is the two variable. So if we have the study of two variables there and we want to compare two variables, or you can say study or simultaneously a study of two variables, then we use, this is known as a study of bivariate, means two variable. We just focus here, we have two variable and we want to study of two variable. So first, what is the correlation? Correlation is the relationship between two variables. Relationship between two variables. Whether the changes in the values of one variable will affect the changes in the values of another variable. If one variable increasing, what is the effect of the another variable? If one variable is decreasing, what is the effect of another variable? So, and this study is known as correlation, just relationship between two variables. Suppose we have two variables, and these two variables, suppose height, one variable is height, and second variable is weight. Now we have two variables, height and weight. If height is increasing, if the values of height, someone's height is increasing. Suppose height is increasing. What is the effect on weight? If the height is increasing, the person whose height is increasing, then what is the effect of their weight? So obviously, if height is increasing, weight will also increase. If height increases, weight will also increase. So you can say that these two variables, height and weight, are correlated. Since the direction of correlation, both variable having the same direction, means height is increasing, weight is also increasing. So both are increasing. So these two variables are correlated. And which type of correlated? This is the positive correlated. Both the direction of the both variables are same. So you can say height and weight are correlated because changes in the height will affect in the changes of weight. That is, if height is increasing, then weight will also increase. So you can say height and weight, these two variables are correlated. There is correlation between these two variables. And which type of correlation? That is the positive correlation because both the direction of the both variables are increasing. Let another example. Suppose income and another expenditure. Here these two variables, income and expenditure. Whether these two variables having any correlation, any relationship. So since if income is increases, expenditure will also increase. If income is increases, expenditure will also increase. Then we can say that these two variables, income and expenditures, are positively correlated because the direction are same. So this is the positive correlations. Let the another example. Price and demand. If there is any relationship between price and demand, so price of any commodity is increases. Suppose if the price is increases, then generally demand will decrease. So here there is relationship because if price is changed, its effect on demand. So price affected on demand. So this, but the direction are different. Price is increases, demand is decreases. So there is correlation, but the correlation is negative. So here price and demand is negatively correlated. This is negative correlation. Here positive correlation. Here positive correlation. If the direction are same, then you can say positive correlation. If directions are different, reverse order, price increasing, demand decreasing, then you can say this is the negative correlation. Pressure and volume, they are also correlated, negatively correlated. Suppose one more example. Marks and crime. See here there are two variables, one is marks and second is crime. So if you see here, there are two variables, marks. If marks is increases, and take another example, another variable, suppose in marks you can just take height. So if marks is increases, then what is the effect on crime? Whether the crime will depend on marks. So there is it seems to be no relationship. So you can say there is no relationship means marks and crime is not related, and marks and crime are uncorrelated means no correlation means uncorrelated. There is no relationship between marks and number of acts crime. So these are the some example of correlations, whether the correlation is positive, negative, and no correlations. Now the second thing is that how to identify the correlation. Suppose here we know height and weight. We know if height is increasing, weight will also increase. But there are so many variables who in the whose ideas are not clear whether what is the changes in one variable will affect the changes in the another variable. So suppose we have two variables and these two variables are denoted by x and y. If we have two variables, one is x and another is y. Suppose height and weight and income and expenditure like this. So here height and weight we already know what is the changes in the height. If the height change, then weight will also change. But if we just give we have just so many variables and we want to know whether the changes in one variable will what type of effect on the changes of another variable. And these two variables are just to be taken as x and y. And the values of x and y is given like this. So one we can also identify the correlation by using the diagram, and this diagram is known as a scatter diagram. So using a scatter diagram, we just have an idea about the correlation. So suppose x and y, the values of x and y are given. There are two variables. We already told you that we have the study of two variables bivariate data, and now these two variables are plotted on the graph. So take x-axis, x on x-axis and y-axis. Now these 2 points, x, the points of x and y, corresponding points of y, means the variable values of x and the corresponding values of y. Suppose, for example, this is 2, this is 4. So x is 2 and y is 4. The corresponding point is like this here. And another point is like this. And this is the not a straight line but a scatteredness. And if we plot all the values, corresponding values x and y, and we see the scatter plot like this corresponding to x and y. So here just you look and see the movement like this. Movement of this graph is upward. Means x is increasing, y will also increase. So we can say the correlation, and the correlation is denoted by R. So we can say R is positive because the movement of this scattered value is upward. If we draw x and y and the plotted value will look like this. This is X and this is Y. So here the movement is downward. Movement is downward. So downward means X is increasing, Y is decreasing. If X is increases, then Y is decreasing. So this correlation is negatively correlated. So R, the value of R is less than 0. The value of R is correlation is less than 0. Here R is positive, that is the greater than 0. Now, if the plotted graph look like this, means there is no any direction. Whether X is increasing, there is no effect of Y. So you can say no correlation. There is no correlation means uncorrelated, and R is equal to 0. Now if you plot X and Y, and it will give you a straight line, not a scattered value, just give you a straight line. This means this straight line is also showing the upward, means X is increasing, Y is also increasing. So here the correlation is R, the value of R is plus 1, positive 1. There are scatteredness. If we concentrate and we minimize the scatteredness, then it will give you a straight line. So, if the corresponding curve of X and Y will look like this, that is a straight line, then the R correlation is said to be perfect positive correlation. This is known as perfect positive correlation, and the value of R is plus 1. If the straight line is look like this downward, then this is known as perfect negative correlation. Means in what ratio X is increases, at the same ratio where Y will decreases. So the relation between X and Y is nothing but a straight line. So this is the perfect negative correlation, and here R is nothing but minus 1. The value of R is minus 1. So if we summarize all this graph from the scatter to straight line, then we see the limit of the correlation. And what we see the limit of the correlation? So limit of the correlation will be minus 1 to plus 1. This is the limit of the correlation. If the correlation is minus 1, that is the perfect negative. If correlation is plus 1, this is the positive, perfect positive correlation, and then will be from minus to plus 1. Now the next question is how to find. This is the graph will only give you the idea about the correlation, whether this is the positive correlation or negative correlation. But the second thing is that if there is correlation, then how strong the relation is. If there is relation, then what is the degree of relation? Positive correlation is just show you the direction of the correlation. Negative correlation just show the direction, but whether this relation is strong or weak. So for finding the degree of correlation, we will use the coefficient of correlation, and this coefficient of correlation is given by Carl Pearson. So for finding the degree of correlation, we use Carl Pearson's coefficient of correlation. Carl Pearson's coefficient of correlation. Using this, we get the degree of correlation. How the relation is strong and whether the relation is weak. So suppose we have two variables x and y, then the correlation between x and y, this is denoted by Rxy. Correlation between x and y, and this can be obtained as the covariance between xy divided by the standard deviation of x into the standard deviation of y. This is the formula. Using this, we will get the degree of correlations. And we expand this. What is the covariance? This is nothing but covariance can be obtained as 1 upon n summation x minus x bar into y minus y bar. And in denominator, the standard deviation x, and we already know the standard deviation can be written as under root 1 upon n summation x minus x bar whole square, and the standard deviation of y 1 upon n summation y minus y bar. This formula can be simplified as the other form, and this can be written as 1 upon n summation x bar minus x bar y bar, and the standard deviation of x 1 upon x summation x square minus x bar square, similarly 1 upon n summation y square minus y bar. You can also simplify in different form, but generally these two formulas always used. Either you can use this one or this one. So by using this formula, we will get the degree of correlation coefficient. So there are some authors who define the range of the correlation, and degree of the correlation is like this. If the correlation, because the limit of the correlation is minus 1 to plus 1. So suppose 0 to 0.4, this consider as the weak correlation. 0.4 to 0.7 is moderate, and 0.7 to 0.8 to 1, this is highly correlated like this. So there are different opinion on this range. Now come to the one example, and we just want to find the correlation between the two variables x and y, and x, the value of x and y are given like this: 2, 4, 6, 8, 10, and y is 20, 12, 18, 10, and 14. So there are two variables x and y whose values are given over here. X is 2, 4, 6, 8, 10, and y is 20, 12, 6. Now the question is whether these two variables, that is x and y, are having any relationship. So just to find the correlation, we are going to use this formula. And from this formula, we want the table accordingly. So here we just x square, y square, and xy. Just prepare the table. X square, that is the 4, 16, 36, 64, and 100. Y square, this is the 400, 144, 324, 100, and 1600. Now xy, 40, 48, 108, and 80, and 400. Now the summation x is equal to what? You will get 30, and summation y is equal to 100. Summation x square is 220, 220. Summation y square 2568, and summation xy 678. Now we also want to know the mean x bar and y bar. So from here you will get the x bar. X bar is summation x upon n, and this is 30 divided by n is 5. This is 6. Similarly, the y, summation y upon n, and this is 100 divided by 5, that is the 20. So mean of x is 6, and mean of y, x bar is equal to 6, and y bar is equal to 20. Now using these value, putting this value in this formula, so our formula is, we just write here. So our formula is R is equal to 1 upon n summation xy minus x bar y bar divided by under root 1 upon n summation x square minus x bar square under root 1 upon n summation square minus y bar square. Now putting the value of these 1 upon n, that is 1 upon 5 into summation xy. Summation xy is 678. 678 minus x bar y bar, that is 6 into 20 divided by the standard deviation of x, that is 1 upon 5 into summation x square, that is 220 minus x bar square, that is 36. X bar square is 36, and here 1 upon 5 multiplied by summation y square, and this is 2568 minus y bar square, this is 20 square 400. Now after solving this, you will get the value 0.504. This is the correlation R x y. 0.50. So this is obviously this is a positive value. So you can say these two variables are positively correlated, but the 0.5, this is not highly correlated. You just moderate. There is moderate correlation. Not x and y are highly correlated. If the value will be greater than 0.7, then you can say the x and y are highly correlated, because here the value is 0.5. So there is obviously there is correlation, but this correlation is not highly. These are moderate. So this is the Pearson's coefficient, and for using this method, you will get the degree of correlation. How the relation are strong and how the relation are weak. So now the next is rank correlation. If the values are and variables, sequential variables are measured on ordinal scale, means if there is ranking and grading. So if there is grading, then we can find correlation as a rank correlation. At the place of height and marks, if they are rankings. So now if the values are given in rank, then we find the correlation using rank correlation. So and this method was given by Spearman. So next is Spearman rank correlation. Spearman rank correlations, and this is denoted by rho, Greek letter rho. So if the values, in place of the values, if there are gradings, then we use as rank correlation. And this is the formula of the rank correlation is nothing but this is just 1 minus 6 summation b square divided by n into n minus 1. Now suppose this is the formula for finding the rank. So take an example. Suppose five students are ranked by two teachers. Five students are ranked by two teachers. So the students five students A, B, C, D, and E. Five students ranked by teacher 1, and the same students are ranked by teacher 2nd. The ranking is like this: 4, 3, 2, 1, 5, and 5, 4, 1, 2, 3. Here the student A was ranked by 4 by the student teacher 1, and the same student A was ranked and given the position 5th by his teacher 2. The second student B, who got the 3rd position in by teacher 1 and 4th position by teacher 2. Similarly, the student C got the 2nd position by teacher 1 and 1st position by teacher 2. So there are two different subject teachers and they are ranked like this to these 5 students. Now the question is whether the opinion of the teachers, if there is any relationship between the opinion of the teachers, their opinion are same or are differ. So for this we just use this formula 1 minus 6 summation d square divided by n into n square minus 1, where d is the difference of rank r x minus rank of x and rank of y. So d is the difference. So here just find the d. What is d? D is the difference of rank and b square. So the difference is 4 minus 5. This is the minus 1. 3 minus 4 minus 1. 2 minus 1. This is 1. 1 minus 2. 1 minus 2 minus 1. And 5 minus 3. 2. Now squaring this. So this is 1, 1, 1, 1 and 4. Now sum of d square. Sum of d square. So this is the 4, 4, 8. So this is the 8. Now putting this value in this formula, then you will get 1 minus 6 summation d square. D square is 8 and divided by n. N is 5. 5 into 5 square minus 1, that is the 24. N into n square minus 1. So solving this, something yes. So this is 5 minus 2. This is 3 by 5. And you can say 0.6. So the correlation and the not rank correlation is 0.6. This is the positive value and good relationship. So here you can say that the opinion of these two teachers are same. The methodology of ranking the students are same because this is the positive value. So the teacher 1 and teacher 2 having the same idea about the student. If the teacher is said someone is good, then the second teacher also say that someone is good. Okay, so this is the correlation and this is the positive correlation. So you can say the opinion of these two teachers are same, and this is the positive correlation. Now next, if the rank is not given and we want to find the rank, then we just convert the values into rank. Suppose we have a data like this marks in mathematics and marks in statistics. The marks of 5 students. Suppose the student is 1, 2, 3, 4, and 5. 6 students. And the marks of in mathematics like this 20, 30, 25, 16, 18, and 10. And the marks in statistics like 25, 28, 16, 15, 20, and 28. Suppose this is the marks. And we want to find the rank correlations. Okay? So this is the marks, not rank. So first we convert the marks into rank. Suppose this marks is given by x and this marks is denoted by y. So here we just convert this mark into rank of x and rank of y. Now how to ranking? Either we rank the maximum to 1 or minimum to 1. So what we just give the rank to maximum. First to maximum. So here the maximum is 30 marks. So this will be given rank 1. Next is 25. This will be given rank 2. Next 20. This is given 3. Next 18. Given 4. Next 16. Given 5th rank. And the last is then given 6. Similarly, the rank of Y. So here also, sorry, here we take this one is, okay, we just change this value because this is repeating and we will discuss the repeating value later on. So here we just give the maximum. The maximum is 30, so it will be given 1. The next is 28, so this is given 2. Next is 25, given 3. Next 20, given 4. Then 16, given 5. And then 15, this is given 6. So now convert these values into rank, grading. Once we get the rank, then we get D, difference of rank. We just directly obtain the D square because in formula we have D square. So what is D square? The difference of rank, the square of the difference of rank. So here difference 3 and 3 and square is 0. The difference is 1 and 2, 1, the square is 1. The difference of 2 and 5 minus 3, the square, this is 9. 5 and 6, the squaring is 1. 4, 4, this is 0. 6 and 1, 5, the squaring is 25. Now, taking summation d square, and this is 10 and 25 and 11. 10, 11, 25, that is the 36. Now find the rank using this formula 1 minus 6 summation d square divided by n into n square minus 1. So 1 minus 6 summation d square is equal to 36 divided by 6n and n square minus 1, that is the 36 minus 1, 35. So this 6 cancel and this is 1 upon 35. So 1 upon 35 is 0.0 approximate 3. So 0.0 approximate 0.03. So this is where obviously this is the positive, but this is approximate and tends to 0. This is the where this correlation is very weak correlation, and you can say there is no correlation because this is approaches to 0, 0.03. So this is very weak correlation, and in analysis you can say directly that there is no correlation. Because if you calculate any variable or the relationship between any two variables, then many times there will be no zero. But the variable, obviously the variables are uncorrelated. But you will not get the value of correlation is equal to 0 directly. So if you get the value approaches to 0 and surrounding the 0, so you just interpret it like no correlations. Now the next is repeated rank. If the rank is repeating, then there is some modification in definitions and formula, and we just take an example about regarding the repeated rank. So if the rank is repeated, So repeated rank. If the rank is repeating, means the same position, same rank is given to more than one student. And so in that case, the slightly modification in the formula, and this is rho is equal to 1 minus 6 summation d square plus summation m into m square minus 1 divided by 12 and 4 divided by n into n square. Only this term is added in numerator. M into m square minus 1, where m is number of repetition of rank. Which rank is repeating how many times? That is the m. If a rank is repeated 3 times, then m is equal to 3. If the rank is repeating 2 times, then m is equal to 2. So just we will take this factor and the formula is same, but just using in numerator m into m square minus 1. For example, just we take an example. Suppose we have two variables x and y, given their values, so that we can convert it into range. And the values are like this: 25, 36, 30, 22, 36, and 15. Here, 18, 20, 18, 15, 16, 17. Suppose these are the values, marks, height, weight, and we want to find the rank. So first we will do what? We convert these values into grading or rank. So first find the rank of x, and we just give the first rank to the maximum value, and you can give the first rank to the minimum value. But this process will apply in both the variables. So here we give the maximum. So here in x 36 is the maximum. So this will be given 1. Next is yes. We just slightly change. Text because this will give you some confusion. So we just take here 25 and this one is 35. We just manipulate these values because it will give you better understanding. So here the maximum value is 36. So it will be given first, rank 1. 36 given rank 1. Next is 30. Next is 35. 35, this will be given second rank. The third, next is 30. This will be given third rank. Now the next is 25. First, second, and third rank already given. The next is 25, and 25 is at 2 places. Here 25, and the next is here 25. So there are 2 places. They are tied at 2 places, and the position is 1, 2, 3 already have been given. So the position for these 2 tie values is after 3, that is 4 and 5. So you can give either 4 or 5. So in statistics, the better representation is arithmetic mean, central value. So we will not give these two values either 4 or 5. We just give the average of 4 or 5. So here the average is 4th position and 5th position is 4.5. So this given is 4.5 and this given is 4.5. Now the 4 and 5th position is given. The next will be given 4 and 5 position is already consumed. So the next will be given the 6. So this is the criteria for and procedure for the ranking. If there is tie, at what place there are tie? So just give the average of that two places. So here the tie will be at the 4th and 5th position. So we just take the average 4 and 5, that is the 4.5. Similarly, the rank of y, and here in y the maximum value is 20, so it given 2. The next is 18, and you just see here the 18 at the 3 places. First 18 is here, then here 18, and the last here is 18. So these 3 18 at the 3 places means, this is given, by 20 is given 1. And the 18, there are 3 18 means 2nd position, 3rd position and 4th position. The value of 2nd, 3rd and 4th position is tied. So we just give the average of 2nd, 3rd and 4th. So 2nd, 3rd and 4th, the average is 2, 3, 4 is 3. So we give 3 to this value, to this 18 and 3 here. So 1, 2, 3, 4 is already consumed. Now the next will be given 5. So 16, next is value 16, this will be given 5. And the last is 15, this is given 6. So this is the procedure for ranking. Now calculate d square, and this d square can be calculated just difference of these two and squaring that. So 4.5 and 3, the difference is 1.5, and 1.5 squaring 2.25. 1 1 0 3 3, this is 0 6 6, this is the 0 2 and 5, this is 3, squaring is 9, and again 4.5 and here 3, 1.5, so this is 2.25. Now taking summation, so summation d square is 13.5. Summation d square is 13.5. Now here first find this correction factor. Summation m into m square minus 1. So just what is m? M is the number of repetition of rank. So one rank, number of repetition. Here this is repeating 4.5 and 4.5. This 4.5, this 4.5 are repeating. How many times is repeated? 2 times. So take m is equal to 2. Here take m is equal to 2. So now find m into m square minus 1 upon 12. If m is equal to 2, then this will be what? 2 into 3 divided by 12. And this is 1 by 2. Similarly, in this range, here you see 3, 3 and 3. These 3 ranks are repeating. How many times? 3 times. So here take m is equal to 3. And from this correction factor, m into m square minus 1 divided by 12. So put m is equal to 3, 3 into 8 divided by 12, and this is 2. Now this is the sum of these. So here 1 half and this is 2. So that is this whole term will be equal to 2.5. This is half and this is 2.5. So now let's put this value in this formula. 1 minus 6 summation t square is 13.5 plus this factor is nothing but 2.5 and divided by n. What is n? N is 6. This is 6 into 6 square minus 1, that is a 35. Now just simplify this. 1 minus 6 into 13.5, 2.16 divided by 6 into 35, and this is, after solving this you will get 19 by 35. 19 by 35, and this is 0.19 by 35. So 0.56 something like this. This is not exact, but we just take this value. This is the approximate 0.5. So this is the correlation and rank correlation when the data are repeated. So in case of repeating rank, you will find the value of rank using this formula, and you will get this is the positive correlation. Now the next topic is regression analysis. So, and I think we will start in the next time. So now we stop here today's lecture, and if you have any query, any problem, then you may ask. And the next topic, the regression analysis, will be start in the next lecture. Okay, thank you. If you have any query, no. Okay, thank you. Let's stop.